Hey everyone, today we will learn about conditionals. So, and conditionals and its transformations. So, what is a conditional? A conditional goes like this. So, conditional is a statement which is expressed in this form. So, let's start with an example. So, for conditional, you click this button in any well form. So, this is our statement, conditional statement. If you click this button, this is the P, then menu will pop up. This is the Q. So the truth table of conditional is P, Q, P, then Q. So you can think of conditional as like this. First, let's input the P and Q values. 0, 1, 0, 1. So if the first part is false, then it as a whole becomes true. If the first part is true, then the final answer will depend on the second part. First part is true, and we will look at the second part, which is 0 and 1. This is the conditional. So you can think of conditional as like this. You can think of conditional as a thing, as a promise which is divided into two parts, the first part and the second part. So this is our first promise and this is our second promise. So for the first promise, if first promise is a success, if the first promise is a success, then a person can break or not break a promise. If the person breaks the promise, then it is 0. If the person makes the promise, it is 1. So this is if our first is 1. But what if our first is 0? What if the first promise, first part is broken? So if the first part is broken, that means it's actually true. Since the overall promise is not complete, or since the first part hasn't even started and second part hasn't even started, so we can think of it like true. Because if something has not started, then we cannot determine if that will be completed or not. Because the one uh, who promised did not even start. So there is a chance he may start or he may not start. So we go with the assumption that the he will complete the promise, and so we put it as a 1. So the final will be 1. This is for conditional. This is the truth table for our conditional statements. So you may think like we have the conditional, then why do we need the inverse, converse, or contrapositive? Well, each and every one of these are important because um, they teach fundamentally that we humans make too much errors. So here is how. Let's look at the converse first. Okay, so the conditional is done. Conditional is done. So let's go to the converse. So converse is since this is the conditional, then converse equals to Q to P. Converse means flipping. So you flip it. P becomes Q, Q becomes P, and vice versa. So this is the converse, the truth table for converse goes like this, and the logic is the same. We use the promise logic, Q to P, 0, 0, 1, 0, 1, 0, 1. So the promise has not started, so we assume it's 1, 1, 1. So since the first part is complete, we look at the second part, 0, 1. This is our truth table. So the truth table is complete. Let's look at why this is needed. So if you think about the conditional, right? The conditional is P to Q, and let's take an example of squares. So if it is a square, then it has 4 sides. Has 4 sides. That is definitely true. That is 100% true, right? This is 100%. This is 1000% true. So, but if we look at it this way, if we flip it, if we use the conversion, then converse becomes Q to P. We flip it. So the converse becomes if it has 4 sides and it's a square. It is telling us that any shape, that has four sides must be a square. So this is not true because if it has four sides, then it may be a square, or maybe a rectangle, or maybe a rhombus, or maybe a trapezium, or maybe a trapezoid, or we don't know. Yeah, so we definitely cannot say that P to Q equals to Q to P. This is not equal. No, this is not equal. So, so what this tells us that our human brains are hardwired to feel that P to Q is equal to Q to P. Because at first glance, what happens then is converse must also be true, but I mean it is true. It is true for one case, but there can be hundred of cases, just like in our previous example where four sides may be a rectangle, a rhombus, or a square, or whatever. So this inverse essentially is like this. We take the conditional, we have the conditional, we just flip them both, negative both. So in if you water the plant, then the plants will okay. This is our this is our plants. This is our P2Q, right? This is our P2Q. If you water the plants, then plants will grow. But the negation of this. So the negation of this is just if water plants will okay. So let me read this out. If we don't water the plants, which is the negation P, then plants will not, which is the negation P. Well, you may like, yeah, man, that is true. What's the problem? So the problem is if you try to understand it closely, let's say if you don't water the plants, okay, this is my plant, uh, this is my plant, and I refuse to water it. So will this die? Maybe, maybe it will die, but but uh, it may get water from humidity. If it does not rain, then maybe humidity will hydrate it, or maybe rain will fall and make these plants grow. So we cannot be definitive that if I don't water the plants, then the plants will grow. I cannot say that if I don't water the plant, then this plant will never grow because there are many factors such as rain and humidity and so on. So this is the same case as like for converse. That means inverse does not equal to converse, and it definitely does not equal to conditional. Yeah, these three are not equal to each other. But we still have one more. Contrapositive. So this is our hero. Hero. This is our hero. Because he saves our day. So what is this contrapositive and its truth table? So contrapositive is let's take P to Q. I don't like this P to Q, so I'll just flip them both and inverse them. This is contrapositive. Okay, so this is the contrapositive. Let's see the truth table. Negation Q, negation P, negation Q to negation P. 0, 0. I got P and Q also at the first. Okay, let's take P 0, 0, 1, 0, 1, 0. So negation 0, 1, 0, 0. Negation P 1, 0, 1, 0. So negation P, negation Q to negation P. Negation so is this one is 0, 1, this is 1, 0. So this is our truth table for a conditional synthesis. But there is one very interesting phenomenon here. So the phenomenon is since our contrapositive is derived from our conditional, which is P to Q, since a contrapositive is from here, and if I put the truth table of P to Q, then let's see what happens. So this is 0, 0, this is 1. So this is 0, 0. 0, 0 is 1, 1, 1, 1 means first part of promise is true. Let's look at the second part. Second part of the promise is 0, then 1 is complete. What can I see here? This mesmerizing beauty. So 1 and 1 is true, 0 and 0 is true, and so that means So does it mean that contrapositive and conditional are the same thing? Well, yes. So contrapositive and contrapositive equals our conditional. This is the main part. Okay. Then, but what is the use? What is the use? I mean, the use. So it's very useful if we want to prove something. You know, there were a lot of proofs, right? So let us take one statement. This is statement. Okay, this is statement. Statement. If n is an even number, then n is equals to an even number. We want to prove this. Let's see how. Okay, if n is an even number, this is one part. If n is an even number, then n squared is also an even number. There is the p and the q part. So the p part and the q part. So the forward order, we go for the forward order, and then we go for the backward order. So you may ask, why do we have to prove it 2 times? Well, because I told you the converse and the conditional are not equal. If you look at this looks like conditional, this looks like converse. They are right, so they are not equal. Okay, let's just prove it. Prove it for the P to Q. Prove it for P to Q, then I must first prove that this n is an even number. So let's assume n is an even number, okay, where a is an integer. And if I then I need to go to this part, the q part, and n squared, and squaring both sides, we got 4k squared. That means n squared equals to 2 times 2 times k squared. Since I need in the form of 2k, I rearrange this form of 2k. Alright, 2 times 2k squared. Okay, let's see. Do we have it? Yes. If you look at it, this is in the form of 2k, where 2k squared is our integer. That means n squared is an even. We proved the first part. Now let's prove the second part. So p to q is q. Now let's look at the q to p part. Now this is where our contrapositive comes into play. Uh, so we have to start from here. So n squared is equal to 2k. If we have to start from here, then what? With rooting both sides, n equals to 2k. Right. So n equals 2. If I multiply the numerator denominator by 2, then it's 4k over 2. Then n equals to 2 root k by 2. So that's it. So what it is? What do we have here? K by 2. So well, we needed n equals to 2k form. We have the 2, but we have k here, and k belongs to integers. And is this an integer? Well, let's look at this root of k by 2. Well, if we put k equal to 3, that's the root of 1.5, and root of 1.5 is, I didn't even know what that is. So yeah, it's not, but I definitely know it's not an integer. So I just block it. I didn't care about it. And I use the contrapositive formula. So Q to P. Let's start Q to P. And since we know the conditional, we can assume this is the conditional. This is the conditional with the contrapositive bit, negation P to negation Q. That means this is equivalent to this. That means if n is an even number, then n squared is also an even number. This is equal to negation. That means if n is an odd number, then n squared is also an odd number. I have to prove it using odd theorem. So, okay, let's start. N equals to 2k plus 1, where k belongs to integer, which is the odd formula, right? 2 times 1 plus 2, 2 times 1, 2 plus 1 is 3, which is an odd, right? So if I, and then I have to go to the negation q part now, and square in even, and square equals to, or square is, this is just 4k squared plus 2 to 4k plus 1. So n square equals to 4k squared plus 4k plus 1. I can take 2 common out here. So 4k squared plus 2k plus 1. Let's check it out. 4k squared plus 2 times 2, 4k plus 1. Okay. This is the integer, right? If we put here 1, then 2 times 1, 2 plus 2, 4. Then 4 is an integer, that is correct. 2 times 4, 8 plus 1 is 9. And square is an odd number, is proved. Okay, we have proved it. That means Q to P is also true. That means whole statement is true. So, to summarize, why contrapositive is important because it helps us prove this statement. And this statement is known as biconditional statement or if and only if statements.